Addressing voltage problems in a marine environment requires a systematic approach. Firstly, it's crucial to conduct a thorough electrical audit. This involves determining the exact voltage drop and pinpointing the specific areas where it's occurring. You need to inspect the wiring, transformers, and connections meticulously to identify the root cause of the voltage drop. Secondly, consider load balancing. Distribute the electrical loads evenly across multiple transformers and feeders. This minimizes voltage fluctuations, preventing some circuits from being heavily loaded while others are underutilized. Thirdly, investigate harmonics. Nonlinear loads, like LED lights and air conditioners, can introduce harmonics, which can impact voltage regulation. If necessary, install harmonic suppression equipment to mitigate these effects. If the existing wiring is undersized or damaged, you'll need to upgrade it. Replace the existing wiring with conductors that can handle the electrical load. Ensure that the conductors are appropriately sized for the voltage and amperage requirements of the loads they serve. Installing additional transformers can also improve voltage stability. Placing a transformer closer to the end of the dock reduces the length of the cable run. This reduces voltage drop along the cable. Another solution is to consider a voltage regulator. A voltage regulator can maintain a consistent voltage level at the dock, even during peak demand. This ensures that all electrical equipment receives the correct voltage, preventing damage and malfunction. It is imperative to implement ground fault protection. Install ground fault circuit interrupters, known as GFCIs, to protect against electrical faults. GFCIs are critical for ensuring safety, especially in a marine environment where water is present. Prioritize safety above all else. Electrical work on a marina requires extreme caution due to potential hazards such as water, corrosion, and high currents. Follow all safety protocols and wear appropriate personal protective equipment, known as PPE. Lastly, it's important to document your work. Keep detailed records of all electrical modifications, inspections, and repairs. This documentation will be valuable for future reference and maintenance purposes. Remember to consult with local authorities. Ensure compliance with all applicable electrical codes and regulations. Marinas are subject to specific electrical codes. Ensuring compliance prevents safety hazards. A more detailed look at these recommendations is as follows. When conducting an electrical audit, use a calibrated multimeter to measure voltage at various points along the electrical system. Record the measurements and compare them to the expected voltage levels. Use a thermal imager to identify hotspots in wiring and connections. Hotspots indicate potential problems such as loose connections or overloaded circuits. Inspect the insulation on wiring for signs of damage or degradation. Damaged insulation can lead to electrical faults and safety hazards. Check the transformers for proper operation. Measure the input and output voltages to ensure that the transformer is providing the correct voltage transformation. Verify that the transformer is properly grounded and bonded. When considering load balancing, analyze the electrical loads on each circuit to determine if they are evenly distributed. Use the clamp meter to measure the current on each circuit. Compare the current measurements to the rated capacity of the circuit. Reconfigure the circuits to distribute the loads more evenly. This may involve moving some loads to different circuits or adding new circuits. Consider using a load management system to automatically balance the electrical loads. Load management systems can prevent overloads and improve voltage stability. To investigate harmonics, use a harmonic analyzer to measure the harmonic content of the electrical system. Identify the sources of the harmonics. This may involve inspecting nonlinear loads such as LED lights, variable frequency drives, and electronic ballasts. Install harmonic filters to reduce the harmonic content of the electrical system. Harmonic filters can improve voltage regulation and reduce stress on electrical equipment. Consider using equipment that is designed to minimize harmonic generation. When upgrading wiring, select conductors that are appropriately sized for the electrical load. Use the National Electrical Code, known as NEC Table 310.15, to determine the correct conductor size based on the amperage and temperature rating. Choose conductors with insulation that is suitable for the environment. In a marina environment, conductors should be resistant to moisture, corrosion, and UV radiation. Ensure that all wiring connections are properly made and tightened. Loose connections can cause voltage drop and overheating. Use appropriate wiring methods and materials for the marina environment. When installing additional transformers, select a transformer with the appropriate voltage and kilovolt ampere, known as kVA, rating. Ensure that the transformer is properly grounded and bonded. Install the transformer in a location that is accessible for maintenance and protected from the elements. Provide adequate ventilation for the transformer to prevent overheating. Connect the transformer to the electrical system using appropriate wiring methods and overcurrent protection devices. When considering a voltage regulator, select a voltage regulator with the appropriate voltage and amperage rating. Install the voltage regulator in a location that is accessible for maintenance and protected from the elements. Connect the voltage regulator to the electrical system using appropriate wiring methods and overcurrent protection devices. Adjust the voltage regulator to maintain the desired voltage level at the dock. Monitor the voltage level at the dock to ensure that the voltage regulator is operating correctly. To implement ground fault protection, install ground fault circuit interrupters, known as GFCIs, on all circuits that serve outlets or equipment near water. Test the GFCIs regularly to ensure that they are functioning correctly. Provide training to marina staff on the proper use and testing of GFCIs. Inspect the electrical system regularly for signs of ground faults. Ground faults can be caused by damaged insulation, loose connections, or water intrusion. When prioritizing safety, wear appropriate personal protective equipment, known as PPE, such as rubber gloves, safety glasses, and insulated tools. Follow lockout/tagout procedures to de-energize electrical equipment before working on it. Use a voltage tester to verify that the equipment is de-energized. Work with a qualified electrician who is experienced in marine electrical systems. Be aware of the potential hazards of working near water, such as electrocution and drowning. Avoid working in wet conditions. When documenting your work, keep detailed records of all electrical modifications, inspections, and repairs. Include the date, time, and location of the work. List the materials and equipment used. Describe the work that was performed. Note any problems or issues that were encountered. Include photographs or diagrams to illustrate the work. Store the records in a safe and accessible location. Consult with local authorities to ensure compliance with all applicable electrical codes and regulations. Obtain the necessary permits for any electrical work that is performed. Follow the requirements of the National Electrical Code, known as NEC, and any local amendments. Work with a qualified electrical inspector to ensure that the electrical system is installed correctly and safely. Maintain a good working relationship with the local authorities to ensure that any electrical issues are addressed promptly and effectively. Considering specific scenarios, firstly, imagine a situation where the voltage drop is most pronounced at the end of a long dock. This suggests that the cable run is too long and the conductors are undersized. In this case, consider installing a step-down transformer closer to the end of the dock to boost the voltage. Secondly, consider a scenario where the voltage fluctuations are caused by heavy loads such as boat lifts or air conditioners. In this case, consider using a load management system to shed loads during peak demand. Thirdly, if the marina has a large number of LED lights, consider installing harmonic filters to reduce the harmonic content of the electrical system. Fourthly, in areas where there is a high risk of corrosion, use corrosion-resistant wiring and connections. Inspect the wiring and connections regularly for signs of corrosion. Fifthly, ensure that all electrical equipment is properly grounded and bonded to prevent electrical shock hazards. When performing electrical work on a marina, always follow these steps. Firstly, de-energize the circuit before working on it. Secondly, verify that the circuit is de-energized using a voltage tester. Thirdly, wear appropriate personal protective equipment, known as PPE. Fourthly, use insulated tools. Fifthly, work with a qualified electrician. Sixthly, follow all applicable electrical codes and regulations. Seventhly, document your work. Eighthly, test the circuit after completing the work to ensure that it is functioning correctly. Lastly, clean up the work area and dispose of any waste materials properly. In addition to these recommendations, it is important to consider the specific needs of the marina. For example, if the marina has a large number of boats with shore power connections, it may be necessary to install additional shore power pedestals. If the marina is located in an area with frequent power outages, it may be necessary to install a backup generator. If the marina is used for commercial fishing or other industrial activities, it may be necessary to install specialized electrical equipment. Also, ongoing maintenance is crucial for ensuring the safety and reliability of the marina's electrical system. Perform regular inspections of the wiring, connections, and equipment. Test the GFCIs regularly. Replace any damaged or worn components. Keep the electrical system clean and free of debris. Provide training to marina staff on electrical safety. By following these recommendations, you can address voltage problems and ensure the safety and reliability of the electrical system in the marina. The National Electrical Code, known as NEC, provides specific requirements for electrical installations in marinas and boatyards. These requirements are designed to protect people and property from electrical hazards. Some of the key NEC requirements for marinas include firstly, grounding and bonding. All metal parts of the electrical system must be properly grounded and bonded to prevent electrical shock hazards. Secondly, ground fault protection. Ground fault circuit interrupters, known as GFCIs, are required on all circuits that serve outlets or equipment near water. Thirdly, wiring methods. Wiring methods must be suitable for the wet and corrosive environment of a marina. Fourthly, overcurrent protection. Overcurrent protection devices must be properly sized to protect the wiring and equipment from overloads and short circuits. Fifthly, shore power receptacles. Shore power receptacles must be of the correct type and rating for the voltage and amperage requirements of the boats that will be using them. Sixthly, lighting. Lighting must be adequate for the safe navigation and use of the marina. Seventhly, signage. Signage must be provided to warn people of electrical hazards. In conclusion, addressing voltage problems in marinas requires a comprehensive approach that includes electrical audits, load balancing, wiring upgrades, and the implementation of safety measures. Following established guidelines, prioritizing safety, and maintaining thorough documentation are essential for ensuring the long-term reliability and safety of the electrical system.